Quantifying and harnessing human-AI work synergy in organizations. Abstract. Organizations increasingly implement generative AI tools to enhance employee productivity. Yet standalone AI benchmark results offer limited insights for real-world deployment. This article examines emerging research on human-AI synergy, the performance gains achieved through human-AI collaboration that exceed what either can accomplish alone. Drawing on recent findings from item response theory frameworks and interactive benchmarks, we analyze when and how human-AI teams outperform solo performance across task difficulties and user abilities. The evidence reveals that collaboration with AI represents a distinct capability from individual problem-solving ability. With theory of mind, the capacity to understand others' perspectives, emerging as a key predictor of effective human-AI partnerships. Organizations can cultivate synergistic human-AI collaboration through structured delegation practices, strategic capability alignment, cognitive complementarity approaches, adaptive collaboration training, and psychological safety initiatives. These evidence-based strategies help organizations move beyond seeing AI as merely a productivity tool toward creating genuine synergistic partnerships that enhance collective intelligence. The rapid advancement of generative AI tools has sparked extensive discussion about their potential to transform work. While early research emphasized AI's role in automating routine tasks, attention has increasingly shifted toward the synergistic outcomes possible when humans and AI collaborate effectively. Executives and knowledge workers alike now face a critical question: under what conditions does human-AI collaboration produce outcomes superior to what humans or AI can achieve independently? Understanding this question has significant implications for how organizations approach AI deployment. Many organizations currently make investment decisions based on standalone AI performance benchmarks that fail to capture the interactive dynamics of real-world collaboration. This approach can lead to substantial misallocations of resources when systems that perform well in isolation perform poorly in collaborative contexts, or when seemingly less capable systems enable significant performance gains through effective partnership. This article synthesizes emerging research on human-AI synergy, drawing from experimental benchmarks and real-world deployments to identify when and why collaboration between humans and AI produces superior outcomes. We examine factors that enhance or diminish synergistic effects, including task characteristics, user abilities, and interaction patterns. Through this evidence-based lens, we provide organizations with frameworks to evaluate AI systems based on their collaborative potential and strategies to cultivate the human capabilities that enable effective partnership with AI. The human-AI collaboration landscape. Defining synergy in human-AI collaboration. Human-AI synergy refers to performance gains achieved through human-AI collaboration that exceed what either can accomplish alone. This concept extends beyond simple efficiency improvements to capture emergent capabilities that arise specifically through interactive partnership. Riedel and Wiedemann, 2025, formalize this as the uplift in human performance when given access to an AI system, accounting for both the AI's direct contributions and the emergent benefits arising from interaction, clarification, and co-construction. Importantly, synergy should be distinguished from mere delegation or automation. In synergistic relationships, both the human and AI make meaningful contributions that enhance the collective output, with each compensating for the other's limitations. This stands in contrast to arrangements where humans simply offload tasks to AI without meaningful engagement, or where humans make only minimal corrections to AI outputs. Prevalence, drivers, and distribution of human-AI collaboration. The deployment of AI collaboration tools has accelerated dramatically, with 49% of organizations reporting some form of generative AI implementation by early 2024. Up from just 17% in mid-2023, McKinsey, 2023. This rapid adoption spans multiple sectors, with particularly strong uptake in technology, financial services, and healthcare. Several drivers have accelerated this trend, The emergence of more accessible large language models, LLMs, with increasingly natural interaction capabilities, growing recognition that AI systems complement rather than simply replace human capabilities, competitive pressures driving organizations to seek productivity advantages through AI augmentation, evolving workplace norms that increasingly accept AI assistance as standard practice while deployment is widespread. The actual impact varies significantly across contexts. This heterogeneity means organizations cannot assume uniform benefits from AI implementation. The distribution of human-AI collaboration also varies by job role and industry sector. Knowledge workers who perform complex but structured tasks, e.g., coding, data analysis, content creation, currently show the highest adoption rates and reported benefits, Brynjolfsson et al. 2023. Meanwhile, roles requiring high emotional intelligence or physical manipulation show lower adoption. Though this boundary continues to shift as multimodal AI capabilities improve. Organizational and individual consequences of human-AI synergy. Organizational performance impacts. Emerging evidence suggests significant performance improvements are possible through effective human-AI collaboration, though results vary widely based on implementation factors. In professional settings, multiple studies have documented substantial productivity gains. Ngo and Zhang, 2023, examined the impact of AI assistance on consulting tasks, finding that consultants with AI support completed 12.2% more tasks on average, with quality improvements of 40% for less experienced workers. Importantly, these gains were highest on complex, non-routine tasks where collaboration between human judgment and AI capabilities proved most valuable. The distribution of benefits shows important patterns that organizations must consider. Brynjolfsson et al. 2023 found that lower-skilled workers often show larger absolute performance gains when using AI tools, reducing performance inequality, while higher-skilled workers maintain their relative advantage and often demonstrate superior ability to leverage AI effectively. This suggests AI deployment may simultaneously raise the floor for all workers while preserving or even widening the performance gap between the most and least skilled employees. Individual well-being and stakeholder impacts beyond performance metrics. Human-AI collaboration shows complex effects on individual well-being and work experience. The impact on employee satisfaction and engagement depends significantly on implementation approach and perceived agency. When implemented thoughtfully, AI collaboration tools can reduce workload stress by handling routine aspects of complex tasks. However, poorly implemented systems can create new stressors through monitoring pressure, loss of autonomy, or skill atrophy concerns. Research by Hancock et al. 2022 found that transparent AI collaborations that preserve human agency and decision authority consistently produced higher satisfaction ratings than systems that obscured their operation or constrained human input. Workers who felt they were working with rather than being replaced by AI reported more positive experiences even when objective task performance was identical. For organizational stakeholders beyond employees, human-AI collaboration introduces new considerations around accountability, transparency, and trust. Organizations must therefore balance performance gains with appropriate stakeholder communications about the role of AI in their operations. Evidence-based organizational responses. Structured delegation practices. Organizations can implement structured delegation frameworks that optimize human-AI collaboration by clarifying when and how employees should engage AI assistance. Evidence suggests that systematic approaches to task assignment between humans and AI lead to superior outcomes compared to ad hoc delegation. Research by Dietvorst et al. 2018 found that allowing humans to maintain some control over AI-assisted processes significantly improved both performance outcomes and user satisfaction. Their findings suggest that strategic task delegation guidelines that preserve human agency while leveraging AI capabilities lead to more effective human-AI collaboration. Effective approaches include task classification matrices that categorize work by complexity, stakes, and required creativity decision trees that guide delegation choices based on task characteristics and constraints, human-in-the-loop, workflows that specify verification points for AI outputs, documentation templates that standardize how employees record AI contributions. Tevan et al. 2022 found that structured approaches to human-AI task allocation improved both performance and user satisfaction compared to unstructured approaches. Their research demonstrated that providing clear frameworks for when and how to delegate tasks to AI systems led to more effective collaboration and higher quality outputs. Strategic capability alignment: organizations achieve superior human-AI synergy by deliberately aligning AI capabilities with human cognitive strengths and limitations. This involves selecting and configuring AI systems to complement specific human capabilities rather than merely automating tasks. Acemoglu and Restrepo, 2018, developed a theoretical framework for understanding human-machine complementarity, arguing that the most productive relationships emerge when technologies address specific human cognitive limitations while enabling humans to focus on areas where they maintain comparative advantage. Their work suggests that cognitive complementarity approaches that identify human bottlenecks and deploy AI specifically to address them produce greater performance gains than general-purpose automation. Effective approaches include capability mapping exercises that document team strengths and weaknesses, AI selection based on specific complementary capabilities rather than general performance, customization of AI systems to address team-specific capability gaps, performance analytics that track synergy rather than individual or AI-only metrics. Research by Amershi et al. 2019 identified guidelines for human-AI interaction that emphasize the importance of matching AI capabilities to specific human needs and limitations. Their work highlights how AI systems should make clear what they can do, support efficient dismissal, and help users understand why specific outputs were generated. Cognitive complementarity training: organizations can develop specialized training programs that help employees cultivate the specific cognitive skills that enhance collaboration with AI. Evidence suggests that focused training on collaborative abilities yields significantly greater returns than general AI literacy programs. Research by Riedel and Wiedemann, 2025, identified theory of mind, the ability to understand another's perspective, as a key predictor of effective human-AI collaboration. Their study found that individuals with stronger perspective-taking abilities achieved significantly higher performance when working with AI, though this advantage didn't appear when working alone. Effective approaches include prompt engineering workshops that develop specific AI communication skills, perspective-taking exercises that strengthen collaborative reasoning, error analysis training that helps employees detect and correct AI mistakes, feedback interpretation skills that improve response to AI outputs. Lubers and Tan, 2019, demonstrated that training users to effectively communicate with AI systems significantly improved collaborative outcomes. Their research showed that users who developed better mental models of AI capabilities and limitations could achieve higher performance through more effective communication strategies. Adaptive collaboration systems: organizations can implement technical and procedural systems that adapt to individual differences in collaboration styles and abilities. Evidence indicates that personalized collaboration systems yield significantly higher performance gains than one-size-fits-all approaches. Bansal et al. 2019 found that AI systems that adapted to users' mental models produced greater performance improvements than static systems. Their research demonstrated that systems capable of adjusting explanations, suggestion frequency, and interaction patterns based on user behavior led to more effective collaboration. Effective approaches include personalized AI interfaces that adapt to individual working styles, collaborative profiles that capture user preferences and strengths, adaptive suggestion systems that modify output based on user feedback, progressive disclosure interfaces that match information density to user expertise. Horvitz, 1999, pioneered research on adaptive interfaces that balance the costs and benefits of AI assistance based on user needs and contexts. His work demonstrated that systems capable of inferring user goals and adapting their behavior accordingly could achieve substantially higher utility than static systems. Psychological safety initiatives. Organizations can cultivate environments where employees feel secure experimenting with and providing feedback about AI collaboration. Evidence shows that psychological safety significantly enhances AI adoption and effectiveness. Research by Edmondson and Leahy, 2014, established the importance of psychological safety in environments characterized by uncertainty and interdependence, conditions that strongly characterize human-AI collaboration. Their work suggests that teams with high psychological safety are more likely to experiment with new technologies, report and learn from errors, and develop more sophisticated collaborative practices. Effective approaches include clear policies that AI use will not negatively impact performance evaluations, team reflection exercises on AI collaboration experiences, recognition programs for identifying AI limitations or improvement opportunities, learning-focused postmortems when AI collaborations fail to meet expectations. Kosielnik et al. 2019 found that fostering psychological safety significantly improved how users interacted with AI systems. Their research demonstrated that environments where users felt comfortable questioning, overriding, or providing feedback on AI recommendations led to more effective human-AI partnerships and better outcomes. Building long-term human-AI synergy. Continuous capability assessment to maintain effective human-AI synergy as both human and AI capabilities evolve. Organizations must implement systematic approaches to ongoing capability assessment. This ensures that collaboration models remain optimally aligned with current capabilities rather than historical assumptions. Alter, 2015, examined how technology affects labor markets and task allocation, finding that successful adaptation requires continuous reassessment of the comparative advantages of humans and machines. As AI capabilities rapidly evolve, organizations must regularly update their understanding of where humans add unique value and where AI systems have developed new strengths. Organizations should establish multidimensional assessment frameworks that regularly evaluate both AI system capabilities and human collaborative skills across different task domains. These assessments should identify both strengths and limitations to guide task allocation decisions and training priorities. Critically, assessments must be updated regularly as AI capabilities evolve rapidly and human skills adapt in response. Regular capability reviews also help organizations identify where AI systems may have surpassed human capabilities in previously human-dominated domains, signaling the need to reconsider task allocation or develop new human roles that leverage emerging complementarities. Collaborative learning ecosystems. Organizations can establish structured approaches for humans and AI systems to co-evolve their capabilities through ongoing interaction. Unlike traditional training approaches that treat human and AI development separately, collaborative learning ecosystems leverage their interaction to improve both simultaneously. Research by Riedel et al. 2021 demonstrated that human teams with strong collaborative dynamics achieved superior collective intelligence outcomes. Their findings suggest that similar principles could apply to human AI teams, where ongoing co-learning enables both parties to develop more sophisticated collaborative capabilities over time. Building effective collaborative learning ecosystems requires organizations to implement feedback loops where AI outputs are evaluated and critiqued by humans, capture patterns in successful human-AI interactions to inform system improvements, develop human capabilities specifically focused on enhancing AI performance, create opportunities for humans to learn from AI approaches to problem solving. This bidirectional learning approach prevents the development of static delegation rules that become outdated as capabilities evolve. Instead, it creates dynamic partnerships where humans and AI systems continuously discover new complementarities through their interaction. Metacognitive infrastructure. Organizations can build systems and practices that help teams reflect on and improve their collaborative processes with AI. This thinking about thinking together approach enables continuous improvement in how humans and AI systems combine their capabilities. Woolley et al. 2010 identified the importance of collective metacognitive processes in driving team performance, finding that teams with strong shared awareness of their collaborative processes consistently outperformed those without such awareness. These findings suggest that human AI teams would similarly benefit from structured reflection on their joint problem-solving approaches. Effective metacognitive infrastructure includes collaboration journals where team members document effective and ineffective interaction patterns, regular retrospectives focused specifically on human-AI collaboration processes, comparative analysis of solo versus collaborative performance on similar tasks, cross-team knowledge sharing about successful collaboration approaches. These practices help teams move beyond viewing AI as a static tool toward understanding it as a dynamic partner whose capabilities and limitations must be continuously reassessed. By making collaboration itself an object of attention and improvement, teams develop more sophisticated mental models of how to work effectively with AI systems. Conclusion: human-AI synergy represents a distinct and measurable organizational capability that extends beyond the separate contributions of human and artificial intelligence. The evidence reviewed here demonstrates that effective collaboration between humans and AI can produce outcomes superior to what either could achieve independently, but this synergy is neither automatic nor uniform. Organizations seeking to harness human-AI synergy should focus on three key principles. First, they must recognize and measure synergy directly rather than assuming it will emerge from standalone human or AI capabilities. The frameworks and metrics introduced here provide starting points for assessing collaborative outcomes. Second, they should cultivate the specific human capabilities that enable effective collaboration, particularly perspective-taking and adaptive communication skills. Finally, they should design technical and organizational systems that support continuous co-evolution of human and AI capabilities. As AI capabilities continue to advance, the greatest competitive advantage will likely accrue not to organizations with the most advanced AI systems, but to those that most effectively combine human and artificial intelligence. By developing a sophisticated understanding of what drives human-AI synergy and implementing evidence-based approaches to cultivate it, organizations can move beyond seeing AI as merely a productivity tool toward creating genuine synergistic partnerships that enhance collective intelligence.